This lesson in engineering science and food. Today we'll be looking at the topic heat and we'll be looking at the April 2021 past exam paper. This is question number 8. Question reads as follows. A copper ball has a volume of 0.685 cubic meters at a temperature of 289 kelvins. If the temperature rises to 347 kelvins, calculate the increase in volume of the copper ball. The first step we are going to do here is look at the given information and check the SI units. So first we are given a volume of 0.685 cubic meters. The next thing I have is an initial temperature of 289 kelvins. Okay, then I have a final temperature of 347 kelvins. So we use T1 to show initial temperature, T2 to show final temperature. VO is a symbol I use for initial volume. Okay, now you find that when we are dealing with heat, every substance has what is known as a linear coefficient of expansion. So every metal expands according to its own temperature based on the material or the substance that you have. Where do you find this linear coefficient of expansion? The correct symbol we'll use for the linear coefficient of expansion is alpha, right? Where do we find this linear coefficient of expansion? This linear coefficient of expansion is found on your information sheet. So if you go to your question paper, you have a formula page followed by an information sheet, and it's called the physical constants. Under quantity, we are going to look for the linear coefficient. We know the substance we are using is copper, and here the constant is given as 17 times 10 to the minus 6 degrees per degrees. Okay, so 17 times 10 to the minus 6 per degree. So that means the coefficient is measured when the temperature is in degrees. So what you will notice here is in this question, the temperature is not in degrees, the temperature is in kelvins. So in the next step, we will now look at the SI unit. Calculates the increase in volume, but before we do that, we are going to look at how to convert from kelvins to degrees. Okay, since our linear coefficient is in degrees, we need to convert from kelvins to degrees. So to convert from kelvins to degrees, we subtract each temperature by 273. So initial temperature is going to be 289 minus 273. My initial temperature is 16. My final temperature, 347 kelvins minus 273, is 74 degrees. Now, when we are calculating an increase, please take note of this keyword. It simply means we are calculating a change in volume. So when we are calculating an increase, we want to know about how much bigger something has expanded by. So an increase is simply the amount by which is expanded. So we are looking at calculating the expansion, which is going to be a change in volume. So if I started with a volume of 2 cubic meters, and I ended with a volume of 8 cubic meters, and I asked you what was the increase in volume. If you had to calculate this increase in volume, you were going to tell me the increase is going to be 8 minus 2. So the increase in volume is going to be 6 cubic meters. So what I've just calculated here is my increase, which is my change. The formula which we can now use to calculate an increase or change in volume based on my given information is going to be the change in volume. So the symbol which we use for change in volume is delta V, is VO, which is my initial volume, multiplied to the symbol here, which is gamma. This gamma now represents the volume coefficient. So every type of expansion has its own coefficient. A linear expansion will have a linear coefficient. An area expansion will have an area coefficient, and a volume expansion will have a volume coefficient. Okay, and we're going to multiply by the change in temperature. Okay, so please do not forget here the T does not stand for time, the T stands for temperature. Okay, so my initial volume is 0.685. Okay, how do we get this volume coefficient? The volume coefficient is simply calculated as 3 times the linear coefficient. Okay, linear is one side, volume is a 3-dimensional object, and our volume is three sides. That is why it's 3 times the linear coefficient. Because remember we said the coefficient does not depend on the shape, but on the substance of the material. So this coefficient belongs to the substance, which is copper. So here it's going to be 3 times 17 times 10 to the minus 6. And the change in temperature is T2 minus T1. So 0.685 multiplied to 3 times 17 times 10 to the minus 6. And now the temperatures in degrees is going to be 74 minus 16. So my increase or my change in volume is simply going to be 2.0 to 6 times 10 to the minus 3 cubic meters. Thank you for watching this video, and if you'd like to receive more videos on this section or engineering science info, please subscribe to my channel.